The check engine light came on, so I began diagnosing the issue. After connecting a scan tool, I retrieved two codes, P0136 O2 sensor circuit, bank 1 sensor 2, and P0137 O2 sensor circuit low voltage, bank 1 sensor 2. These codes pointed to an issue with the downstream oxygen sensor, which monitors the efficiency of the catalytic converter. To gather more information, I performed a road test while monitoring live data from the oxygen sensor, B1S2. During the test, I observed that the sensor's readings were erratic, confirming that the sensor wasn't functioning properly. My next step was to inspect the wiring harness and connector for the sensor to check for any visible damage, corrosion, or loose connections. Everything appeared intact, so I moved on to further testing. With the ignition on and the engine off, I used a multimeter to test the sensor connector for voltage and ground. Both were present, confirming that the circuit was providing power and ground as expected. To verify the condition of the sensor itself, I checked its continuity using the multimeter. The test showed that continuity was not present, indicating that the oxygen sensor was faulty and needed replacement. Based on these results, I replaced the oxygen sensor with a new one. After the replacement, I cleared the fault codes and performed another road test to confirm the repair. The vehicle operated smoothly, the oxygen sensor readings were stable, and the check engine light stayed off. No fault codes returned. This repair demonstrates the importance of the downstream oxygen sensor in maintaining proper emissions and engine performance. A faulty sensor can lead to poor fuel efficiency, higher emissions, and an illuminated check engine light. By systematically diagnosing the issue, I was able to pinpoint the problem and resolve it effectively, ensuring the vehicle returned to optimal performance.